are welcome to session 4 under unit 1, types of aromatic compounds. At the end of the unit, you should be able to mention the types of aromatic compounds, give example of aromatic compounds, and then identify other cyclic molecules and ions which do not contain benzene ring as aromatic compounds or not. So the first type of aromatic compound we'll be looking at will be the neutral homocyclic aromatic compounds. And these are compounds that basically have just carbon and hydrogen in them. These aromatic compounds consisting of just hydrogen and carbon. And then, of course, they have the alternating double bond as well. So benzene and most anilines belong to this group. However, cyclodecapentaene is an exception. It's not an example of this group and considered not aromatic. The next group of aromatic compounds we'll look at are the heterocyclic aromatic compounds. These are basically a different atom other than hydrogen and carbon. So we have some aromatic compounds that have oxygen or nitrogen or sulfur replacing the carbon in their structure. And there are even cases where there are more than one heteroatom present. So any heteroatom present in an aromatic ring makes the compound a heterocyclic aromatic compound. Next will be fused aromatics and polycyclics. Now, polycyclic aromatic compounds are aromatic compounds containing two or more simple aromatic rings fused together as one, and then they share carbons atom at the point where they join together. So typical examples are naphthalene, anthracene, nantrene. These are the basic fused aromatics and polycyclic compounds you can think of whenever you talk about fused aromatic compounds. Next will be the substituted aromatic compounds. So there are aromatic compounds, certain aromatic compounds have a whole lot of substituents on them. Benzoic acid is an example. We have paracetamol as also an example, and then TNT, also an example of substituted aromatic compounds. Last will be aromatic ions. So an aromatic compound does not necessarily have to be neutral, but there are cases where certain ions attached to the ring make the ring aromatic. So a typical example is in cyclopentadienyl anion. So there are basically two pi electrons here, another two pi electrons here, making 4, and then this pair of electrons as well. So basically this compound is an anion, alright, but it has 6 pi electrons which are involved in resonance. So we see that the pi electrons here are delocalized. They are not localized, they are delocalized, and they help in the resonance formation in the structure, making the compound aromatic. So we have aromatic anions as well, or aromatic cations, collectively being referred to as aromatic ions. So example is this cyclopentadienyl anion. Another example is cycloheptatrienyl cation,